viewers, how are you all? Hope everybody is fine staying at their homes. Dear friends, in this video, we are going to discuss about another concept that helps us to understand and interpret many natural phenomena like work. Closely related to work are energy and power. In this chapter, we shall study about work, energy and power concepts. Friends, to perform various activities and to do work, humans need energy. This energy for these processes comes from the food we eat. But what about machines? Do they also do work and require energy like us? Yes, of course they do work and they require energy too, that is the electric current. Friends, in these sentences I was using the term work for many times. But what do we actually mean by the term work? Work is said to be done when the point of application of force is displaced, or a force is said to be work if, when acting, there is a displacement of the point of application in the direction of force. Let us take an example. Ravi was working hard to push a huge truck. The truck does not move despite all the effort. Ravi gets completely exhausted. However, Ravi has not done any work on the truck as there is no displacement of the truck. Lakshman was sleeping on his bed. Do you think Lakshman had done any work? Of course no, because there is no force acting on him or by him and there is no displacement. Santosh has climbed the tree. In this case, do you think Santosh has done any work? Yes, Santosh had done work because he had both force and displacement in one single direction. A force should act on an object and the object must be displaced. If any one of the above conditions does not exist, work is not done. Let a constant force F act on an object. Let the object be displaced through a distance S in the direction of the force. Let W be the work done. Therefore, we can define work done as force into displacement. That is, W is equal to F into S. SI unit of work done is joule. 1 joule is the amount of work done on an object when a force of 1 Newton displaces it by 1 meter along the line of action of force. A force of 15 Newton acts on a train. The displacement of the train is 10 meters. Calculate the work done by the train. We know that work is equal to force into displacement. Force acting on the train is equal to 15 newtons. Displacement of the train is equal to 10 meters. Therefore, 10 into 15 is equal to 150 joules. Therefore, the work done by the train is 150 joules. If the force and displacement acting on a body is in the same direction, then the work done is positive. If the force and displacement acting on a body are in different directions, then the work done is negative. Now let us discuss about the concept of energy. When a balloon is filled with air and when we press it, we can notice a change in its shape. If we press the balloon hard, it can even explode, producing a blasting sound. In this example, the balloon acquires the capability of doing work. Therefore, we can define energy as the capability of doing work. An object that possesses energy can exert a force on another object. By doing so, the object possessing energy can do work. SI unit of energy is same as that of work, that is joules. Mechanical energy is divided into two different types, potential energy and kinetic energy. The energy possessed by an object by virtue of its position and configuration is known as potential energy. The energy possessed by an object by virtue of its motion is known as kinetic energy. Let a body of mass m be situated on the ground. Let it be lifted to a height h by a force F. From this diagram we can obtain that work done by the force W is equal to F into S. Friends, remember that force is always due to gravitation. So we can write force into gravitation into displacement. According to our diagram, height is equal to displacement of the object. So we can write F into G into H. Force is nothing but mass. So force is equal to mass. So we can write m into g into h. This work done on the object is stored in it as potential energy. So therefore potential energy is equal to mgh. Let a body of mass m be moving with an initial velocity of u. Let a force F act on it for t seconds. Let the velocity change to v due to the force. Let S be the displacement during this time. From the diagram, from the equation v square minus u square is equal to 2as, I am taking the 2 to the left hand side so that as is equal to v square minus u square by 2. By multiplying with mass m on both sides, we get mass is equal to m by 2 of v square minus u square. Mass into acceleration is nothing but force. So in the place of ma, we can write F. And on the right hand side, by opening the bracket, we get half mv square minus half mu square. So Fs is equal to half mv square minus half mu square. Force into displacement is work. So in the place of Fs, we can write W. So W equal to half mv square minus half mu square. In the equation 1, if the initial velocity u is equal to 0, that is, if the body is at rest, then work done is equal to half mv square. This work done on the object is stored in it as kinetic energy. Therefore, kinetic energy is equal to half mv square. Now we shall discuss about the next concept, power. Power is defined as the rate of doing work or the rate of transfer of energy. Power formula can be obtained by work done per unit time. Work is nothing but force into displacement. So we can also write that force into displacement by time is power. Displacement by time is velocity. So we can write that force into velocity is also power. The SI unit of power is watt, in honor of James Watt, a Scottish inventor having the symbol W. Watt can also be represented by joules per second and even Newton into meter per second. Friends, do remember this. Commercial unit of electrical energy is kilowatt per hour, but SI unit of energy is joules. Relation between commercial unit of electric energy and SI unit of energy. 1 kilowatt per hour is equal to 1000 watts into 1 hour. Since 1 hour is equal to 3600 seconds, therefore 1000 watts into 3600 seconds. That is 3.6 into 10 to the power 6 joules. Therefore, 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joules. Now let us discuss about the law of conservation of energy. This law states that energy can neither be created nor be destroyed but can only be conserved from one form to another. I have took 3 points A, B and C respectively. Height from A to C is h. Now I have dropped the stone from A to C and I have marked 3 points A, B and C. Now let us calculate the energy of the stone at the point A. So total energy is equal to kinetic energy plus potential energy. When the stone is at the point A, I did not release it. So the kinetic energy will be 0. So the total energy at point A is potential energy. Now I had released the stone. The stone has become stationary at point C. Now let us calculate the total energy of the stone at point C. Since the stone has come from the state of motion to the state of rest, potential energy will be 0. So therefore total energy at point C is kinetic energy. Question. 2 bulbs of 100 watts each, a fan of 80 watts are used for 5 hours a day. A geyser of 1000 watt is used for 1 hour daily. A TV of 60 watt is used for 2 hours daily. Calculate the electric bill of the month of November at the rate of Rs 2 per unit. Friends, I am not telling the answer of the question, but I will say the hint of the answer. Dear friends, with the help of the hint, try to do the answer and let me know the answer through the comment section. If you say the correct answer, I will pin your comment and your names will be released through the next video. Dear friends, hope you liked the video. And don't forget to subscribe Ganesh Study Rankers and activate the icon bell. Thanks for watching.